All right, so the second half of this section, we're going to talk about how to use lines of fit. Scatter plots can show whether there is a trend in the set of data and whether it goes up or down, so positive correlation or trend, and negative correlation or trend, or if the points are everywhere, like we said before, there's no correlation, there's no real trend there. So when the data points all lie close to a line, so you can see that there is definitely a correlation there, you can a line of fit or a trend line can model that data, can model the trend. So here's the four-step process, and this is just kind of breaking it down into pieces so that you can more easily do this. First, you make your scatter plot and determine whether a relationship exists in the first place. If there's no relationship, you really can't talk about a line of fit if there's no correlation, okay? But let's assume there is. Then you want to draw a line that seems to pass close to most of the data points. Again, you want one straight line. You don't want to try to connect all the points with like a zigzag line or anything like that. It doesn't have to be perfect. In fact, the line doesn't even have to touch any of the points. For example, if you had points like that, I would draw a line right through the middle of those points so that it passed through or passed as close to as many of the points as possible. Okay, so you don't exactly have to touch any points. You can have your line pass through 1 or 2 points. It can pass through 3 or 4 points. Just draw a line that, when you look at it, looks like it gets as close to as many points as possible. Then just pick 2 points off of that line to write an equation for that line. Okay, if you have 2 points, you can use point-slope form. The 2 points to get the slope, and then one of those points with the slope to write the equation of the line. And then once you have the equation of the line, you can plug values in that to make predictions. Okay, so let's look at how we do this. This table shows the largest vertical drop of 9 roller coasters in the United States and the number of years after 1988 that they were opened. Identify the independent and dependent variables. Is there a relationship in the data? If so, predict the vertical drop in a roller coaster built 30 years after 1988. Okay, so here's the data. If we want to make a scatter plot, the independent variable is the year, so that's kind of like your X, and the dependent variable is the vertical drop. That's like your Y. And as you could see from the scatter plot here, in general, as the number of years increases, the vertical drop of roller coasters increase. So in other words, they made bigger, higher roller coasters as the years went on. So there is a positive correlation between the two variables. Second, we're going to draw the line of fit, which is already on here, and you could see that the line actually passes through 1 point here, but doesn't pass through any other points on the scatter plot. So when we go to write the equation of the line, we're just going to try to eyeball 2 points on this line to get the slope. Okay, so like I said before, no one line is going to pass through all the points, so we just draw one as close to the points as possible, like the one there, and then rewrite the slope-intercept form of the equation for the line of fit. Now the line passes close to the point 2, 150. Now remember, we're just estimating. It's pretty close. I know it doesn't go exactly on there, but that's okay. And also 12, 300 is pretty close right there. So we'll use those 2 points, calculate the slope. So y2 minus y1 over x2 minus x1. When you get that, you get 150 over 10 or 15. Then we can use that with either point from the point slope form, or either point from the 2 points to write it in point slope form or slope intercept form. So here's what we did. We took the point slope form and used the point 2, 150 with a slope of 15. Then distributed the 15 and added 150 to get it in slope intercept form. So a vertical or a slope of 15 means that the vertical drop increased an average of 15 feet per year. It means each year, it's like in general, each year the roller coasters got higher by about 15 feet. So to predict the vertical drop in a roller coaster built 30 years after 1988, substitute 30 for x in the equation. So you do 15 times 30 plus 120, or 570 feet. Okay, so what we did here was we took the data, made a scatter plot, drew a line of best fit, basically took 2 points on that line, picked any 2 points, got the slope, and then slammed them into the slope intercept form, or point slope form, and then solve for y to get it in slope-intercept. And then we plugged in the number that they asked us to estimate it for using our equation to get our answer. Okay? All right, so in section 2, we learned that a linear extrapolation is used to predict values outside the range of the data. You can also use a linear equation to predict values inside the range of data. This is called linear interpolation. Okay, so extrapolation is when you're trying to predict data values outside the range of the data. So that's what we did in this example right here. We only went up to 15 years after 1988 with our data, and we predicted what would happen 30 years after 1988. That's beyond the data that's given. So that would be extrapolation. Interpolation is, you see how they gave us 1, 3, 5, 8, 12, 13, and 15, those years? Well, if I wanted to predict how high the roller coaster would be at 10 years, given this information, that would be linear interpolation. And that's what we're going to do here. So we're going to use this scatter plot to find the approximate number of United States travelers to international countries in 1996. So here, these are years since 1990, so this would represent 95, 2000, 2005, 2010. Okay, so 96 would be right here a little bit after 5, and you can see there's no data value there. So what we did was we have the scatter plot. We drew our line of fit on there. Remember, we're just estimating that. And then from that, we're going to write an equation and then plug in 6 years after 1990, to estimate the number of travelers to international countries in 96. So we drew the line of fit, and that, again, that's as close to as many points as possible. You may have drawn it a little bit more up here. That would be fine, no big deal. So write the slope-intercept form of the equation through the line that passes through these 2 points. So we used 0 and 44,623, as well as 18, 63, 554. Now, those are probably 2 points that they had from the data values. That's probably how they got those numbers, because it's kind of hard to eyeball 63,554 just by looking at it. Okay? So let's assume that they had a table of values they were working from. So we find the slope, y2 minus y1 over x2 minus x1, and 18,931 over 18. We're just going to leave that fraction like that. If you wanted to convert it to a decimal, go ahead. That's fine. No big deal there. So we use that as the slope and the y-intercept as our other point. Put it in point-slope form. Solve for y, and you get this as your equation. Then step 3, evaluate the function for what would be 1996, or 6 years after 1990, since the graph is in terms of years after 1990. If we wanted to do 96, that's 6 years after 1990, so we just substitute 6 into our equation of best fit line, multiply and simplify, and you would get 50,933 and a third. So since that's in terms of thousands, that would be 50,933,000 people who traveled from the United States to international countries. Okay? All right, so what we did here, just to review with you real quick, is we already had the scatter plot. If we didn't, if they just gave us a table of values, we would plot those, make our scatter plot. Draw a line of best fit, like we did previously. Take 2 points on that line of best fit. Remember, your line of best fit wants to go close to as many points as possible. It doesn't actually even have to hit any of the points. If it does, that's great. If it doesn't, that's fine as well. Then take 2 of the points, calculate the slope, and then take the slope in one of those points, calculate the equation of the line, and then use that equation to figure out the value that they asked you for. Linear interpolation is whenever you're trying to figure out a data value that's within the values they give you. So we went from 1990 to 2010, so any values that are in that range would be linear interpolation. If I wanted to go and predict what 2050 would be, that'd be linear extrapolation, because that's beyond the values in the data set. All right. Well, that's it, guys. Please reach out if you have any questions, and make sure you continue on to your assignment. Take care.